Hello everyone, in this video we are going to solve the today's lead code problem, that is find largest value in each tree row. Okay, the question it says that given the root of a binary tree, return an array of the largest value in each row of the tree zero indexed. Okay, the question states that we are given a binary tree. What is binary tree? A binary tree is a tree which have at max two child nodes. Like in this one, it has two children. Three, it has two children. Two, it has one children. Nine, it has no children. So it can have 0, 1, or 2 children. Okay, nothing more than that. Okay, and what we need to find is we need to find the largest value in each row. Like in this row, 1. In this row, what is the maximum value? 1. So we store 1 in our list. In this row, 3 and 2, what is the maximum? 3. So we store 3 in our list. In this row, what is the maximum? 5, 3, 9. Our maximum is 9. So we store 9 in our answer and return this. So answer is 139. Okay. So let's take an example and let's understand. For example, we have an tree, something like that. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what is the maximum in this row? 1. What is the maximum in this row? 3. What is the maximum in this row or in this level? 5. What is the maximum in this level? It is 8. What is the maximum in this level? 7. So our resultant list will be 1, 3, 5, 8, 7. Okay, let's take another example like 1, 2, 3, 4, 5, 6, 7. What is the maximum in this? 1. What is the maximum in 3? What is the maximum in this? 7. So our resultant will be 1, 3, and 7. Okay, so let's wait. So whenever we need to traverse level wise, or we can say row wise, like here we traverse every level. Like this is our first level, this is our second level, this is our third level, this is our fourth level. So whenever we traverse, the first algorithm which comes in our mind is BFS, that is breadth first search. So we are going to solve this, and we can also solve this problem using DFS, but for the simplicity purpose or easy, we solve it using BFS. And if you don't know this algorithm, I highly recommend you to please first understand this algorithm and then watch this video. Okay, let's move to the code part, and after the code we are going to write on that the code. Okay, so let's move to the code. So first of all, we need to create an resultant list which we are going to return. That is ours. And what if our root is null? Then what we can do? We can return the empty list, and we can simply return the resultant list. As if root is not null, then what we can do is we can create an queue of type tree node, and we can add root to the queue. Then what we can do next is while queue is not empty, we can do is int cur max for finding the maximum value. What we can do is we can set initially it as integer dot min value, max minimum value of integer. Okay, and we find the size of the queue, and from here we can traverse to each level or each root of each child nodes of a node, each child node of a node. Okay, so here what we can do is we can remove the child from the queue, and we can update cur max by mat.max of cur max comma, here we need to store in node of value. Okay, what we can do next is if node node of left child of node is not null, we can simply add to the queue dot add node dot left. If node dot right child is also not null, and what we can do is we can simply add node dot right to our queue. Okay, and what after all, we can add result, we can add cur max to our result, and simply after all the traverse should be return our result. Let's run this code. Oh, error, not a statement result. Wait, line number 21. Okay, here we need to return this. Next, let me submit the problem. So it passes all the test cases. Let me try run this code. Okay, so let me explain the code. Oh, sorry. So let's make. So we create, what we do initially is we create a resultant list. Resultant list. What is this? This is initially we create resultant list, which is initially